Hey guys, I just want to go through our notes on dividing rational expressions. These will be pretty quick. We'll just do 5 quick examples. So, to start us off, like we've been doing, I'll show you something that's kind of lame to illustrate a point, and then we'll go for it for the rest. So, say I was doing just a regular division with fractions, like 5/4 divided by 3/2. Remember that we keep, change, flip is the method. So, keep the first fraction as 5/4, change the divide into multiply, and then flip or find the reciprocal of the last fraction. So multiplying by the reciprocal is same as dividing by the original. And now we can do everything that we did before, which is look for canceling here. So I can divide each of these by 2 and no canceling here. So I've got 5/6. So that's the game plan. Keep, change, flip, factor, cancel, simplify. Let's jump into an actual example then. How about one like x squared minus 14x plus 48 over x squared minus 6x divided by 3x minus 24 over 1. All right, so let's see. First off, I shouldn't have written the 1 yet. Imagine the 1 wasn't there and it didn't look like a fraction, just put a 1 under it. From there, though, the very first step is keep, change, flip. So I'll keep the first guy. Change it to multiply, and then flip it. And if I were you when you're doing the bookwork, this is what the book will give you. I wouldn't even write that down because immediately you're going to have to rewrite it. So if you want to write this down, you're just going to have to redo it again. So I would just look off the book, keep, change, and flip it before you write it down. It'll save you a lot of paper space. So let's do some factoring here. It looks like we have a trinomial we can factor, an x we can pull out, and this one I don't see anything we can do. So let's factor this guy on top first. So factors of 48 that add to 14. I'll have to go through the factors of 48. We have 1 and 48. You have 2 and 24. 3 doesn't go into it. 4 and 12. That should work. 4 and 12. Oh no, 4 and 12, that won't work. 3, we already tried. 4, 5, 6. And nothing goes in with 6. Oh yeah, 6 and 8. That'll work. 6 and 8. So I need a 6 and an 8, and they're both going to have to be negative. On the bottom, I can pull out an x, and I'm left with an x minus 6. And then over here, we already said this one was already simplified, so I can just rewrite and look for some things to cancel. Here was my canceling. And then at the end, you can just shove everything together. So you have 1 times 8 minus x, which is just 8 minus x, over x times 3x minus 24. All right, let's do another one then. All right, here's my original. So I've got x squared plus 6x minus 27 divided by 3x squared plus 27x all over x plus 5. Right off the get-go, notice there's no 1 under this one, so you can write a 1 in, and then go ahead and do your keep, change, flip. So don't mind me while I rewrite this again. Like I said, I would, on your bookwork, just do the keep, change, flip before you write it down. All right, so that's done. Kept it, changed it, flipped it. Now you got to factor it. Or you could write it down the original way and then factor it in your next step. Either way. So let's see. We want to factor the top. So factors of 27 that add to 6. That'll be 9 and 3. I'll need a positive 9 and a negative 3. Over here, x plus 5 is already simplified. Then on the bottom, I can pull out a 3x. So I've got an x plus 9 on top and bottom that can go away, and that's it. So on the top, I've got x minus 3, x plus 5. And on the bottom, we've just got a 3x. All right. These don't get too much crazier, but maybe instead of doing another problem, I'll just remind you again of those special factoring cases. Maybe we need these. So this shows up inside problems. One of them is difference of squares. So for example, the setup is a squared minus b squared. And an example of that would be if I had x squared minus 9. This would factor into being x plus 3, x minus 3. So in the formal way, it'd be a plus b, a minus b. So there's one of them. The next one is sum of cubes. So sum of cubes, a cubed plus b cubed turns into a plus b times the quantity a squared minus ab plus b squared. And the last one, I guess we should do an example. So say we had x cubed plus 27. Our a term would have been x and our b term would have been 3. So we would do x plus 3 times x squared plus 3x plus 9, except I forgot to put a minus here. Maybe I'm out of ink. Oh, struggles. Well, you get the idea. That's supposed to be a minus. How about that? Last one, difference of cubes. So like a cubed minus b cubed is very similar. The first one's going to be a minus, so a minus b. And then the rest are add. And an example of that, say we had x cubed minus 8. Our a term is x and our b term is 2 in this case. So you've got x minus 2 times the quantity x squared plus 2x plus 4. So those are our special factoring ones. Those show up inside of problems somewhere. You maybe have one of either of these in your top or bottom of your fraction of your problem, and that's how you'd factor those. So that's something to watch out for. The difference of squares one is probably the most straightforward because you can kind of imagine you're just trying to cancel out to get a like 0x term. So like multiples of 9 or factors of 9 that add to 0, 3 and negative 3. These ones we did the proof of a while back, and I'm not going to bore you with that again, but there it is. I hope this helps for your homework today, and I will see you tomorrow.